On screen we have a frost refrigeration system through the hot gas bypass. What is the hot gas bypass system? It consists of making a bypass of the discharge gas from the compressor and directing it towards the evaporator in such a way that the temperature of the discharge gas, which is usually above 60 or 70 degrees Celsius depending on the refrigerant and the pressures depending on the efficiency of the cycle, passes through the evaporator and manages to increase the temperature to quickly eliminate the frost of the exchanger of this point. So it works as we are seeing. We have the output of the semi-hermetic compressor that we are seeing on the screen. We find a bypass. I am showing the gas at the moment the dewatering is needed opens this solenoid valve. When this solenoid valve is open it allows the discharge gas to be directed. Let's continue the pipe. It is directed at this point the hot gas at high temperature. It has a high pressure since it comes from the discharge and the gas will then be directed towards the evaporator with the highest pressure and the highest temperature. Then we are going to raise the temperature there. This is going to be quite fast and we are going to eliminate the frost. The gas that comes out of the evaporator will go out through the half-inch suction pipe that we are seeing in this case and it reaches the compressor. To improve the efficiency of this system what we are showing is very basic. To improve the efficiency of this system, we must place a KBL type valve before the compressor to prevent the compressor from absorbing such high pressures. So before the compressor we put a KBL valve. This can be further improved because it can be placed in the bypass of the hot gas bypass. At this point a valve can be placed that allows us to supply the hot gas regularly so as not to flood the evaporator with steam. What happens? When the refrigerant arrives, the first refrigerant that arrives will be found. This refrigerant will be found with a low temperature. The first hot coolant that arrives is going to be met with a low temperature because we actually want to remove the ice. As the refrigerant rises sharply at this temperature it is very likely that the refrigerant undergoes a phase change, phase from superheated vapor to liquid, then to saturated liquid. So there when we need to place accessories before the compressor that allow us to ensure the useful life of the equipment. For this reason it would be recommended to place a liquid accumulator in the suction to prevent the gas that can condense in the evaporator as a result of sudden cooling from passing to the liquid phase and reach directly to the compressor. And also in many systems we will see the location of a KBL type valve to avoid high pressure in suction. So this system that we are showing, as we mentioned, is quite basic because it does not include the other accessories that it should have. But it helps us to understand how the hot VIPA system works as the thermostat, depending on the programming, turns on the solenoid. Should voltage be applied to the solenoid, then the defrost process will start with the bypass gas. The good thing about this system is that the defrost is fast and we are not going to stop the compressor. This is quite important in higher capacity systems. If we are familiar with low-capacity equipment, then the defrost is done by turning off the compressor and using electrical resistances or even by stop time. But in larger equipment it is not so convenient to be turning off the compressor and we also need to defrost more quickly, so this is an alternative, of course. We must place the accessories that are required to extend the life of the compressor and to be able to optimize this process. Removal of frost on the evaporator.